We have talked about numbers and how rationals come from the fact that we need to understand division. And the more you understand division, and the more you understand how represent division as fractions, the more you understand why rational numbers are needed. However, we need to know how to demonstrate when a number is rational or not. And in this video, we're going to see how repeating decimals are rational. Okay, last time we talked about rationals and how we have some rational, any rational could be represented as a fraction. And we let the space to know whether repeating decimals are fractions or not, or are rationals, because they are not fractions, they are repeating decimals. But if we can express it as fractions, then we can tell that they are rational. So we're going to see the strategy to convert these numbers into fractions, if it's possible, of course. So we're going to start with this example. Let's say that the number you have is 0.555 periodic, or 0.5 and above. The first thing that I'm going to ask you to understand is that we can call this number the number x. Okay, so for simplicity, I'm going to write the x here. Now, what happened if I multiply this number by 10? So, what happened if I make 10x? Observe that if I multiply by 10, this number, it will be moving the decimal point one place to the right. So the new number will be 5.555 until infinite. And now look at that, my period is the same after the decimal point. So I can subtract, or I can rewrite here x, that is my 0.5, repeat it. And look at that, I can only subtract to have 9x on the left side equal to 5. Look at that, I can simplify these 5s. So I'm going to get 5, 0, 0, 0, 0. And now I only need to divide by 9 to get that x is 5/9. So 0.5 periodic is going to be 5/9. And here I have demonstrated that a periodic, a repeating decimal, could be expressed in the form a over b, in which a is an integer and b is an integer. Therefore, 0.5 belongs, periodic belongs to the rational numbers. But maybe you can say, hey, but you choose an easy exercise, it's just 0.5 periodic. Let's do another that it will be more difficult, another in which we need to do more computations, or in which the period is different. Okay, let's see another. What happens if the number is 1.345 and the only one that is periodic is the 45? So it will be something like 1.345 45 45 infinite. What would you do? Why don't you think a minute what would you do in this case? Remember that we're using the strategy of setting this number equals x. So what would you do? Think a little bit. What would you do? Okay? So look at that, my period repeats after any 45. So what I'm going to do is that I'm going to compute my x by numbers in a way that after my decimal point I got my period that is 45. So what would be the first number I could try? I could try multiply by my number by 10, and then I can try to multiply by number, look at that, here is the period, by 10, 100,000. So I can multiply 1000x, and here I'm going to multiply 10x. Okay, look at that, I'm having after the decimal point only my period, and here I multiply after my decimal point the period. Look at that, I'm using 45, so it should be repeated the 45. You cannot multiply by 100 because you're gonna have 54. So let's see, what do we have? If I multiply by 1000, I'm gonna get, I forgot to show you, so let me repeat again. X will be 1.345 is the period, and in this case 1.34, the period will be repeated here, 45, 45, 45. So I'm going to multiply by powers of 10 in a way that I have my decimal points here. Okay, my decimal point. After the decimal point I'm gonna have my period, that it's 45. So I decided to multiply one of the numbers by 10. So I have 45s here. I have only 45s here. And on the other side, I multiply by 1000 to get only 45s here. Okay, so let me show you. If I multiply by 1000, it will be 1, 2, 3. So 1345. And now 45, 45, 45 till infinite. And if I multiply by 10, I'm gonna get 13.45, 45, 45. Look at that, my strategy is to have all my period to be subtracted after the decimal point. That's the goal, because if I subtract it, I'm gonna get 0, 0, 0, 0, 0. So in this case, it will be 5 minus 3, that it's 2. 4 minus 1, that it's 3. And 3. So I have 1,332. And here I'm going to have 1,000 minus 10x. 1,000 minus 10x is only 990x. Okay? And now I'm just going to divide. So let's divide. And I'm going to have that x is 1,332 over 990. Remember that the best way, the best way that you can show a fraction is by simplest form. So I'm going to put it in simplest form. So to put it in simplest form, I'm going to divide by 2. So it will be 6. 13 again, divide by 2, 6, divide by 2, it will be 1. Okay, and here I'm going to divide by 2 again, so 4, it's going to be 1, 9 is going to be 1, and here is going to be 5. So I'm gonna get 661 over 495. Okay, let's see, this number is not divisible by 11, so that's it. That would be our fraction. So as a conclusion, 1.345 periodic, it's just 661 over 495. So we just demonstrate that 1.345 periodic belongs to rational numbers. And this is the main idea of how you can demonstrate that two numbers, that the repeating decimals are rational numbers. But that's going to lead us to another question. That's pretty good. We have test rational numbers. So could we use this information to simplify expressions? Could I create any expression in the rational number system and simplify it using these facts? Or I could do it better? This is what I'm going to show you in the next video. Have a nice day. See you soon. Bye bye.